Today we're taking a look at section 10.3, which is displaying data part 2. Really just a continuation of 10.2. We're going to continue on looking at different kinds of graphs and thinking about like when they're used, what they're useful for. So the first one, not to be confused with a line plot, which we saw, dot plot, line plot description before. This one's called a line graph. A line graph is line segments connecting one data point to the next, typically showing the trend of a variable over time. Think connect the dots. So that phrase, typically describing a trend over time, is really important because that's when you see line graphs used. If you wanted to track the stock market's a place where you see line graphs used a lot. We've seen line graphs used a lot lately when they've displayed data from COVID testing. So when you're looking at something, how it's changing over time, you see line graphs used frequently. We're going to do a set of data. This one's time over which we're being used is a particular week. It says a learning specialist tracked the average reported study times of her students. Create a line graph for the data she tracked. So possible option as you're doing your homework would be to use some graph paper. You might find that easier to use. You certainly don't have to, but sometimes people like the structure it gives their work. If you don't have graph paper and you certainly don't want to go pay $2 for a little package of it for one section of material, you can print graph paper off from online. It's very easy to find. Just look for graph paper images or something like that and you can print it. I actually have graph paper right here. So we're going to use some graph paper to create our data. So you've got your data written down and I've still got mine as well, so I'm not going to keep flipping back and forth. But what we're going to do is we're going to create an XY vertical horizontal axis, much like we did with like histograms and stuff like that. And I'm going to try and line it up on the lines, which was the whole point of using the grid paper. And the time is the independent variable. It's the part that's changing at the bottom. So we're always wanting whatever time measurement we're using to be along the x-axis at the bottom. So this one is actually measured as days of the week. It could be weeks, right? Weeks since we started tracking COVID data. It could be years that a stock market, a particular stock has certain values over time, things like that. So lots of things we could be using, but some kind of a time measurement on bottom. So I'm going to mark every other one for my data. So this is Monday, Tuesday, Wednesday, Thursday, Friday. I don't have enough lines, so I'm going to move it over. This should be Saturday and Sunday. So here's Saturday and then Sunday. And then if you look at the data that you're given, it's actually the hours spent studying. And just like on, I'm already doing it, but let me just make emphasis to the fact that just like on the other graphs, we need to label the x and the y axis with the units of what we're actually calculating, what's being measured. And if you take a look at the data, it's actually measuring it in quarter-hour increments. So we see we have 1.5, 1.75, 0.75, 2, 0.25, 0.25, and 1.5. So it seems quite reasonable that we would mark off every quarter as a measurement. So, and I'll label every other one just so that my measurement labeling doesn't get overly complicated or overly small. So this would be 0.5, this would be 1, this would be 1.5, and this would be 2. Still feel like I'm running into my labels. I'm going to shift this over. Okay, I'm mostly pleased with that. Except that I didn't get the bottom lined up on a line segment line at all. You don't have to do this when you're writing things out, which is both a positive and a negative, isn't it? All right, let me try one more time. Okay. If I don't touch it, might work. So we're just going to plot the data. So the first set of data is, how did that happen? I'm off on all my line pieces over here. Okay, I have absolutely no idea. These look terrible now. I'm just starting over on that. All right, 0.5, 1, 1.5, and 2. All right, stop touching. All right, the first one was Monday, and it was 1.5 hours. So on Monday, we're going to make a dot at 1.5 hours. The second one was Wednesday, and it was 0.7 hours. I'm sorry, Tuesday, and it was 1.75 hours. So that's right here. And then we have Thursday. Wednesday is 0.75 hours. I'm wanting to skip days. Wednesday is 0.75 hours. I think I must have made my scale messed up when I did this because they're all just a little bit off. I must have made them like expanded when I was shifting. Okay, 0.75. So Wednesday, 0.75 would be, oops, right here. Thursday, 2 hours. Up here. Friday says 0.25 hours, which I'm quite sure has to be a lie because I don't know any students who study on Fridays. That's just silliness right there. And then Saturday is 0.25 hours. And then Sunday, everybody tries to make up the ground that they weren't doing during the weekend, and so we have another hour and a half. So something of that nature. And then according to the description you saw earlier, we're going to connect the dots here in order, time order. So we're going to connect Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, Friday to Saturday, and Saturday to Sunday. And that's our line graph. Now, this isn't a very exciting line graph, but what you're tending to look for when you're looking something like this is trending values, right? So you're trying to look at sort of over time. It was very interesting at one point during all of our quarantine time in the spring is that I actually graphed daily numbers instead of weekly total numbers for COVID, and there's no trend. It looks like this. It's chaos. It's like up and down all over the place. It's crazy. And so I very quickly decided that was absolutely worthless, looking at daily values. And so when I looked at weekly values, there was much more of a trend. You could actually see how the weekly values were trending instead of a daily values, which weren't at all. And so there are certainly line graphs that don't provide useful information. But like that's why you see stock market stuff and they look at trends over time. Or sometimes you will see a line graph where it's comparing what happens in the first quarter of this year to the first quarter of next year to the first quarter of the next year. So if it always goes down in the first quarter, then that's an expectation and you're not terribly concerned if you're in the stock market and you're in that particular stock. Because you know during the first quarter that nobody's buying swimsuits in January, right? No big deal. So that kind of stuff. So this is a line graph. Any questions on that one? Yes, we do need a title. Thank you for reminding me. Yep, let's do that next. So what would the title be for this kind of a graph? This data. Okay, so it's the study time, so the time spent studying. You can say by students if you want, something of that nature. Yeah, we do need a title. Thank you. Okay, any questions on that? Okay, I'm going to move this because I'm going to use the same grid here in a moment. No, you think I just deleted it. I really didn't. Look, now it's right there where it wanted to be to begin with. That's better. Okay, so there's our line graph without the grid. All right, our next type of a graph is called a scatter plot. Scatter plots are often used when a relationship between variables cannot be easily depicted even by a broken line. So what we had before we might define as a broken line or line segments. And so sometimes data just doesn't present itself that way, but scatter plots can still sometimes give us the sense of if something's increasing over time or decreasing over time, that kind of thing. And that's called a scatter plot. So this is an example of some data. Coach Lewis kept track of the vertical jump heights of his starters over 8 years. So from 2002, that's 7 years. I don't even know why it says 8 years. That's 7 years of data. I've used this data for a lot of time, and I've never noticed that. Over 7 years. So we've got from 2002 to 2008, and he has his 5 starters. So this would be basketball, right? Vertical jump height, most likely anyway. I suppose it could be pole vaulting. Maybe it's pole vaulting. We'll go with basketball. So what we're going to do is we're going to actually create a scatter plot of this data. And grids are going to be very helpful for this. If you don't have it right now, obviously it's not a big deal. But just keep that in mind that grids can be useful. This is the vertical jump height in inches, by the way. That was accidentally left out. So this is inches of vertical jump height. So what we're going to do is we're going to create, this is still over time, so it's the 2002 to 2008. So I'm going to create a graph that goes from 2002 to 2008. And because it's spread out such that it is, I'm going to skip every other one for each of my years too, just because it makes it a little easier to draw it in my values. So this is 02, 03, 04, 05, 06, 07, and 08. Okay, so far so good? Looking at my data, I need to know where to start. So I need to know what the smallest value is and what the biggest value is in order to have a reference point for my graph. So what do you guys see for a smallest value? We'll start with that one. I think 60 is the smallest that I see, this one right here. What's the largest? 77 over here. From 60 to 77 is a significant jump, by the way. 17 inches is almost a 1.5 foot difference in jumping height, so it's big. So I need my graph to go from 60 to 77, which means that unlike, say, the study graph one I just did, where 0 was the x-axis, and I just did my 0.8s, 0.25s up from there, I need to make sure that what I'm showing actually shows that there's a break in my graph. So the first thing I'm going to do is I'm going to draw a break in my graph, because it's not going to be zeros on the x-axis. It just isn't. So these are my years. It's really years after 2000 the way I've written it down, right? Because I've put O and then the number each time, so this is years after 2000. So we've got 60 here. And I'm going to make one hash mark for every height, and then, but I'm not going to label them all. 61, 2, 3, 64, 65, I'll label every 5, 65, 66, 67, 68, 69, 70. Hope we have enough space. 71, 72, 73, 74, 75, good. 76 and 77. So I have enough height. I do need to label them. So on the bottom I did my label. On the right hand side this is vertical jump height. You definitely need to include, to include the units. So this would be in inches. Right over there. Okay, and we're just going to plot a whole bunch of points. Now the interesting thing here is, of course, for every year I'm plotting 5 points, right? So in the year 2002, I have 5 different points to plot. In the year 2003, I have 5 different points to plot, and so forth. So in 2002, I have 65, 63, 60. So 65, 63, 60, 62. Oh my goodness, did we miss one? I missed it. Did you guys miss it? 58. I totally missed it. Okay, so let's make a couple of adjustments real quick. I think I can adjust this down just a little bit. At least that's what my goal is going to be. I think that'll do it. This is messy over here. That's terrible. Pretend like that's not terrible, but it's terrible right now. So here was 58. And I need that break in the graph like I had before. It just needs to be the break between 58 and the x-axis. Looks like it's broken down there. It's not a very good break, but pretend. All right, so I had a 62, which I didn't mark yet, and I had a 58. Next column, I have 67, 65, 65, 64, 66, and 62. The next year I have 67, 68, 66, 65, 64. Then I have 68 and 70. 67, 66, and 65. And then I have 70, 68, 67, 69, and 66. Wow, jumped up a lot. 74, 72, 73, 70, and 69. Something's off. Let me try this again. Okay, I had 74, 72, 73, there it is, 70 and 70, 69, here we go. And then I have 77, 75, 72, 71, and 70. Yuck. What a bunch of dots. Dots everywhere. Okay, that's a scatter plot. Scatter plot's just a plot of dots, and it needs table. So let's draw a table real quick. Or not table, draw a title. So I meant to say a title real quick. These are the vertical jump heights in inches for Coach Lewis's basketball, well, we assumed, we'll just say starters. I don't think it said basketball, I assumed it. Yeah. All right, it says what kind of association is there for this data? I skipped that question over here, maybe because it was on the next page. No, it's just on your paper. Association means what's happening over time. Does it trend upward or does it trend downward? So what is it doing over time here? It's going up. It's trending upward. And so what we actually call that is a positive association. So the association here is positive. So not positive because it's a good thing, but positive because as the time increases, the other value goes to increase as well. If you were trying to model this with some sort of a, shading, it would have a line, kind of a shading going uphill. It's increasing. That's why that would be called that. So let me actually define for you what's going on with the next one, and then we'll actually do this next time. A trend line is actually a line that tries to closely fit the data from a scatter plot specifically, and it can be used to describe it. Sometimes you'll hear this data called a best fit line. So in general, what we would want to do if we were trying to sort of predict what the starting would be for, the starting, what the vertical jump height would be for the starters for the next year, right? You would do a prediction. We'd kind of like to figure out what's going on with this graph. And so what we're doing in this next part that we'll do next time is we're going to try and fit a line to this. Now, it's not going to hit all the dots. In fact, it may hit none. That's okay. But it's trying to get the overall sense of what's going on. Like, this is not a trend line for the data. The data doesn't look like it's doing that, right? But something like this seems quite reasonable. Okay, we're eyeballing things here. That is all we are doing. If you were in a business calculus class, I'd show you exactly how to do it with a calculator. It's actually really cool. But this is an eyeball approximation kind of an activity here, best fitting lines. So what we're going to do next time is we're going to take this best fitting line that I just drew, and I just sort of plopped it down there, right? But it seems pretty reasonable, wouldn't you say? It looks like it's pretty good. Now my line and Gracie's line and Josie's line, they may not look exactly the same, and that's perfectly okay as well. But what we're going to do next time is we're going to actually find an equation for a specific line and write down a best fit line for this particular set of data. We'll pick back up there next time.